This is one of the first major hurdles every Flutter developer faces. When you stack enough text, buttons, and images, the layout eventually exceeds the physical boundaries of the device. This triggers the overflow error, marked by the yellow and black striped caution tape at the bottom of the screen. This error occurs because Flutter layouts are static by default. To fix this, we need to transition from a fixed screen to a scrollable one. Let's set up a test case in VS Code. Create a new screen and add a column widget. Inside the children's list, paste enough text widgets to ensure the content extends well past the bottom of your emulator or physical device. Seeing that error tape is actually a good sign. It confirms that your content is structured correctly, but simply needs a scrolling container to be accessible to the user. The most immediate fix is to wrap your column inside a widget called Single Child Scroll View. This adds a vertical scrolling mechanism to your existing layout without changing any of your internal code. Look at this diagram. Your phone screen is a fixed glass window with an unchangeable size. The Single Child Scroll View treats your content like a long paper scroll. It slides behind the window, revealing hidden items. While this works for short screens like settings or login forms, it has a performance limit. It renders the entire scroll immediately. If you have thousands of images, the phone tries to load and hold all of them in memory at once, eventually leading to a crash. For better performance, we use the list view. Think of it as a combo meal. It gives you the vertical stacking of a column and the scrolling of a single child scroll view in one widget. This room service menu demonstrates the list tile inside a list view. It provides 4 specific slots, a leading icon on the left, a bold title and subtitle in the center, and a trailing zone on the right for prices or arrows. Wrapping a column is a quick way to stop a crash, but using a list view with list tiles ensures your data remains organized and easy to read as the list grows. Hard-coding every item works for a static menu, but most apps get data from the internet. If you have 500 rooms in a hotel database, you cannot manually write 500 list tile widgets. To handle dynamic data, we use listview.builder. This works like an assembly line robot building the specific items currently visible. As you scroll, it builds the next item appearing at the bottom and dismantles the one disappearing at the top. This recycling process is called lazy loading. By only keeping a few items in memory at a time, your app can handle massive lists without using excessive system resources. The builder requires 2 pieces of information. First, item count tells it how many items are in your data list. Second, item builder provides the blueprint or code for each individual row. Inside that blueprint, the robot uses a variable called the index. This counter tells the builder which specific piece of data to pull for the current row. Because the system only renders what the user is actually looking at, your app stays responsive, whether you have 10 items or 10,000. While a list view stacks items vertically, a grid view allows you to place them side by side. This is the difference between a scrolling social media feed and a multi-column photo gallery. To control this layout, we use a tool called the Silver Grid Delegate. While the name is complex, its primary function is to define the number of columns on the screen. By adjusting the cross-axis count, you change how the grid is divided. If you set it to 2, the items automatically resize to fill half the screen width each. This process is similar to a factory stamping machine. Your custom card code is the cookie cutter, and your raw data is the dough. The builder repeatedly presses that design onto every piece of data in your list. You only need to design the layout for a single card once, choosing the shadows, images, and text styles. The builder then repeats that design for every item, injecting the unique name and photo for each row. Using custom cards and grid layouts allows you to present large amounts of data in a way that is visually engaging and efficient to navigate. You've now covered the core widgets for managing overflow and building high-performance lists. You've moved from static screens to layouts that can scale with any amount of data. This live hotel directory is the result. It uses a listview.builder to recycle formatted UMetti cards, providing a smooth experience even when fetching data from a web server. Now that we have a functioning list, we can move to the next phase, where these list items will act as buttons that navigate the user to specific detailed views.